All right, so we are given that these two angles are equal. That's right here. We're also given that S and T are equal. So we mark one with 1, we mark one with 2. We say angle 1 is congruent to angle 2. We say angle S is congruent to angle T, and we say that's given. We also mark this. We have an angle here, an angle here, an angle here, and an angle here. Okay? And then we always look for what we can mark, and we can always mark this side, ZR. And then once we mark it, we just say ZR is congruent to itself. And that's by the reflexive property. Remember, anytime you write reflexive, it's only when you have something equal to itself. All right? So only when you write something equal to itself. You're never going to say AB equals CD reflexive. It's not. It's always going to be something equal to itself. Okay? And so then we have a side. And if we follow this along, we have angle, angle, side. Angle, angle, side. So we're done. We have proven this triangle congruent, these triangles congruent in a few easy steps. In fact, only one extra step other than what was given to us. And we say it's by AS. All right. Moving on to number 2. We mark what we're given. So we mark TR is congruent to SR. We're also told that Z is the midpoint. Okay, so we write our congruent statement, our statements down here, TR congruent to SR. And we say that Z is the midpoint of TS. All right, and then we say that's given. Remember, as soon as you read that something is the midpoint, immediately, eyes on this, please, immediately mark this. You know those two pieces are equal to each other immediately. And then immediately after you mark them, write it. ZT or TZ, however you want to say it, is congruent to SZ or ZS, whatever. Definition of midpoint. Because think about it. You marked them because you were told the term midpoint. So since you know the definition of midpoint, you can mark the two segments equal. And then I need to use 2 here because I used 1 here and 1 here. And then I always look for this, and I have it. So I say ZR is congruent to itself, just like before. And that is by reflexive. I can spell. Reflexive. We're done. We have S and S and S. S, S, S. So we can say triangle RZS congruent to triangle RZT. Okay? And that is by SSS. Moving on to number 3. So, given AB is parallel to DC, and AB is also congruent to DC. That's given. All right? So, first off, we're going to mark AB with a little triangle here and DC with a little triangle because you're given that. And immediately when you see the term parallel, extend your lines out, extend your transversal just to remind you of what we've done in the past. And then we have this equal to that by AIA. We know that. And since there's not anything else going on at that angle, we can just say angle A is congruent to angle D by AIA. So we have that angle marked, and we have it marked by AIA. We also, don't forget, we're given this, so we mark this, there's a lot going on, equal to itself. So what do we have here? We have a side and a side. We have an angle and we have an angle. And then we have our magic thing we always look for. We have vertical angles right there. Now, in this case, we cannot say angle O equals angle O because there's too many angles there. So we say angle BOA, or if you want to, you could just use this same, since O is in the middle, you could use that same verbiage and say AOB. Doesn't matter. But notice if I go BOA, I'm going to go COD. Congruent to angle COD. And that is by vertical angles are congruent. And again, if you wrote definition of vertical angles, I would accept that too. Well, there's another A. Well, we got what we need, AAS. So we can now say triangle AOB or BOA, whatever you want to do, AOB is congruent to triangle DOC, and that's by AAS. Again, if you just take it step by step, you mark everything, you label everything, it practically writes itself. I know proofs are hard at first, but once you get in the habit, it's really not that bad. All right? So we have B as the midpoint of AD and CE. Look at that. B is midpoint of AD and CE. We don't usually get that very often, but we do this time. So this is the midpoint of EC, so I can mark each of those segments equal. But look, there's more. I can also mark these two on AD because it's the midpoint of both. This is given. What do I always mark when I can? I mark the vertical angles. And I'm going to use this verbiage because B is in the middle. So I'm going to say angle. I'm just copying, really. I just changed the triangle to an angle symbol. ABC is congruent to angle DBE. And again, why? Because vertical angles are congruent. And guess what? We're already done. SAS. All right, so we have our SAS. Now, once we mark these, remember to go down here and just say real quickly, EB, and you can do this all in one line also. EB is congruent to BC, and DB is congruent to AB, and that's definition of midpoint. I should have done that immediately like I stressed on the last one, but forgot to. So there we go. Again, once you mark it, you write it, and we're done. We have triangle ABC is congruent to triangle DBE, and that's by SAS. And again, I just read it, SAS, SAS. Just follow the order. All right. Great. I don't know why I got cut off. Okay, so... All right, so it's a little cut off here, but you have it in your packet. It says angles 3 and angle 4 right angles. So angle 3 and angle 4 are right angles. It also says XC, bisects, why am I writing congruent? XC bisects ACB, angle ACB. That's given. All right, so XC bisects ACB, that's up here, ACB, I'm exaggerating again. That means angle 1 and angle 2 are equal. So just like when we say midpoint, but then we have to say the things are equal, we need to say angle 1 is congruent to angle 2, definition of angle bisector. So just like midpoint, we have to write out the two sides equal to each other, definition of midpoint. Here we must say those angles are equal, definition of an angle bisector. Now technically, if you skip this, I would not hold it against you, but technically we should say angle 3 is congruent to angle 4. It's kind of one of those duh things. Right angles are congruent. Every right angle is congruent because they're all 90. Okay, so I would not hold it against you if you did not write it again, but technically, to be specific, you should say they're equal to each other. So that you can put angle here, angle here, angle here, angle here, and then what are we going to do? Our famous old reflexive. We say that XC, besides being a bisector, is also equal to itself. Why? Because it's the reflexive property. Anything is equal to itself. And that gives us ASA on both triangles. So we're done. We can say triangle ACX, and we're just copying that from the top, is congruent to triangle BCX. That's a K, not an X. There we go. And that's by ASA, angle, side, angle. I believe last but not least. Yes, last but not least. Here we go. Number 6. Numero 6. We know that CA is equal to CB. So CA equal to CB. Boom. CA equal congruent to CB. We also know that CX is perpendicular. Remember, that's the upside down T is the perpendicular symbol to AB. So if it's that, then we know those are both right angles. So that's given. Okay, so we should say angle 3 is congruent. No, sorry. Can't jump the gun. Angle 3 and angle 4 are right angles. Definition of perpendicular lines. And again, technically, like the previous one, we really should say angle 3 is congruent to angle 4. Again, duh. All right angles are congruent because they're all 90. And then we have our old favorite, CX is congruent to CX. And that's the reflexive property. Now, let's label it. We have angle, side, side, angle, side, side, and we run into a problem because there is no ASS rule. But wait, there's more. Since this is a right angle, the triangle is a right triangle, and remember, the hypotenuse is always directly, it's almost like this is like a bow and arrow. Like if you think about this is the bow and here's the arrow, it's shooting that way. If you follow the direction of the bow, it's shooting this way, and that's the hypotenuse. So really, this is H and this is H. We can't use ASS, but this is a leg and this is a leg. We're using this as the leg. So now we are saved. If this was not a right triangle, if they just said angle 3 and 4 were equal, we couldn't do anything. All right? But since we have right triangle, we can now say that triangle CAX is congruent to triangle CBX by HL.